Well, Ms. Jones, look like you and I are the only two in the class today so far. But this chapter, okay, here we go. It's Nunez. Okay, all right, there we go. And make sure you sign the roll too. All right. This chapter is on functions, all right, on modular programming. And we went over this earlier in the semester, but when you write your program in modules, what you're doing, you're breaking it down into smaller pieces, all right? It tells us that a program may be broken up into manageable.
Empezó mi clase, pero igual.
Somebody. All right. So it says a function is a collection of statements that perform a specific task.
No.
Okay.
La otra se la perdí, pero.
Somebody. Mr. Nunez.
Eso es medio importante, pero.
Mr. Nunez.
Ya lo que está perdió está.
Mr. Nunez.
El otro semestre.
Mr. Nunez.
Es que es mejor.
Hello?
Retirarme. Y que no me quede en mi historial.
You need to mute your.
No retirarme y tener una F.
Wow. Mr. Nunez.
Estoy.
Still on him. Hold on.
De Blaze.
Wow.
¿De qué ocupamos?
Mr. Nunez.
¿Qué polvo ocupamos?
Oh, man, this is. All right. Okay, class. So it tells us a function is a collection of statements that perform a specific task. Okay. So far you've experienced functions in two ways. All right. One, you have entered a function name, all right, named main, and in every program that you've written, because main is a function that's needed for every C++ program. And you've also used library functions such as the power function, even the string function, the string compare function. Those are just functions that's already written that you've called. And we've already also written some of the user-defined functions. All right. So functions are commonly used to break a problem down into smaller, manageable pieces, right? Instead of writing one large program, you could break it up into small pieces, almost like, say, writing a book. You don't write just a whole book. You write it in chapters, right? So you break it down into the different chapters. A similar concept, all right? So here, if you notice, they show a comparison. This is one large program, all of the statements in the program, line by line by line by line. It could have whatever, if statements or whatever, but it's just one large program. But then if you look here, just pretty much that same program, and it's broken down into different functions, and the different functions may handle different tasks. Okay, so defining and calling a function. Okay, so some things you need to know before you can start writing functions. Well, you've really written one already, the main function. This would be your function header. Okay, int would be the value that you return, and most time when we wrote the int main, we had to what? Return 0. So this shows that what? An int value will be returned once this function is completed. The function name is main. And what arguments are we passing? Or, there's no argument list or parameter list. But then we have our body, a beginning of the body and an ending of the body. Okay, so that's the format. Now, void functions. When you use void, it just signifies that there's no return value. All right, you wouldn't have returned anything in a function that has void on it. You would get an error because it doesn't know what you're telling it here, that you're not returning anything. Right? If you notice in this particular defined function, you have void display message. If you would have like return and any type of value or whatnot, here you would get an error because you said what? Void. There's nothing being returned. Okay? So in this little function, you got your function header, nothing being returned, your function name, and no argument list. Okay? There's no arguments in the list. And then this is the body, the begin and end, and this is what it's doing. All it is doing is printing out hello from the function, display message, and then creating a new line. That's all it's doing. All right. When you call a function, all right, when you call a function, you just simply use the function name and the argument list if there is one. If not, just open and close parentheses. Example, all right? So look here, in this program, this is our defined function. Void, which is nothing being returned. Display message, which is the name of the function, and no argument list. And then we have our body, okay, of our function and what it's doing. So if we go to the main function, in the main function, we see cout hello from main. But then you see the name of that function that we defined up here called display message with no void or int or anything in front of it because you just have the function name, the argument list, semicolon. So what happens after it executes this cout statement here, it says, okay, go to or call the display message function, go here, perform whatever in here. Okay, so it's going to output hello from the function display message. Okay, when I get to the end of it, I'm going to return, even though I don't use the word return because I'm not returning a value, then the program returns execution back to the next executable statement, which is this cout statement, which is back in function main again, new line. And then the return 0 returns a 0 to the end of the main and the program's end. Okay, so let's look at this in online GDB. So we go to online GDB, all right? And so we have our, let's close this. We have our function, our main, our little structure, right? Every C++ program have what? Its main function, right? Int, return 0, no argument list. So if you looked at the program that we just looked at, that we just reviewed in the notes, it defined the function at the beginning of the program. There's no problem with that, all right? The only exception with that is you have to have your functions in the proper alignment, meaning in the proper order, if you do it that way. And that's the only disadvantage of doing it that way. But you can give the prototype and then define the function at the bottom of the program, of the main or outside of any other function. Either way works, but like I said, if you're going to define your functions here, I cannot define a function with a variable name that is to be used and it's defined in the function that I'm defining afterward. It's kind of like I have to introduce a variable that I'm using or passing before I call or use the function. So that's what I'm simply saying. So if you define your functions at the beginning, then you have to have them in the proper order so that the program could declare the variables in its proper order and know what variables is being used at the time. You can do the prototype, which would be something like this. I could say, I'm gonna create a function to output just some text. I'll just say void, and I'll say display one. Display one, right? That's a prototype. But then down here, I would have to create my function definition, void display one, no argument, all right? And I wouldn't put a semicolon because I'm defining my function. So here, I would define the function and I could say, cout enter display one function, all right? So, and then what? No data type. So I'm just returning back. I'm not returning a value. All right. So now in here, I have to, in order to use the function, I have to call it. So to call it, I would simply do what? Display one. All right. So now, in doing this, here's my prototype. Okay, I have a function that it's say like I'm declaring a variable. I'm kind of declaring the function. It's void, the name is display one, and there's no arguments. Okay, void display one, here's my definition. And then to call it, display one, and no arguments, semicolon. So if I run this, and let me just put a cout statement at the end, cout. All right, this say program has ended. Okay, so when we return back to the main, we're gonna output program has ended. All right, and I'll put a /t here. Okay, so if I run this, all right, hopefully all the errors are out. Okay, scroll up. And I'll run this. All right, so notice what happened. Define this, declare this function. Then we got into the int main. We called this function. Where's the function definition? Down here. And what it actually does? It outputs entered display one function. Okay, and look, enter display one function. Once it does that, then it gets to the end here and it returns back to the next executable line, which outputs two new lines. All right. Well, this one, that's one now, then two more new lines here, and then outputs program has ended. So you see what happens? You declare the function, define it down here, but then you call it. Now, the way the book did it, we could take this out and watch what happens. I could move this here, because with it down here, it's never being actually declared. So I need to cut it from here, and I can paste the definition here. So now the program knows what this is, because it's what? It's executing this header file, loading the name, the standard libraries, And then it says, okay, rather than me say declare void, whatever semicolon and declare down here, I'm doing it all in one process in a sense at this point. So void display one and whatever. So it's actually kind of like telling the program or the compiler, this is a function that I have and this is its definition. So I don't need to do the prototype. And the program should run the same. So when I run it, I'll get the same exact output. All right. So you see, I get the exact same output. But my statement was prior to this, if I had multiple functions listed before the main, and if I had a variable that, say I had display one, display two, and display three, and in display one was trying to reference a variable that was being introduced in display three, I would get an error because display one would not know that it was being introduced. So things of that nature you have to be aware of, right? But like I say, you can do the prototype of the functions and list them all, and you can eliminate that situation, right? Now, this is just the standard, okay? Your function prototype, and like I say, that's what we did the first time. I'll click here. All right, function prototype, function definition, and this is the function call. Now, when you're dealing with variables or need to deal with some values, there's several ways you can write your code. To write code with global variables, and sometimes you may need to, that allows a value or a variable to be used throughout the program. Example, if I did something like this, int total, or I'll say int num1, and I'll say equals 3, my fault, 3, num2 is equal to 8, right? So I have two values that are declared, but if you notice, these values are actually declared outside of any function, outside of the main and outside of this function here. So these variables would be called global variables. When we talked about global variables and local variables before and the scope, we'll see what happens when we deal like this. All right, so now, and I'll do something like this, comma sum equals 0. All right, so I'll do something like this. So we have num1, num2, and sum. So what we can do is, all right, I can use num1 and num2 anywhere in the program. So if I write a program, I told you to write a program declaring all your variables global, I could just write a function without what? Passing values, and I could do something like this that says total is equal to, if I could type, num1 plus num2, all right? So being that that's global, that would be no problem because what? I can call these variables from anywhere in the program. Then I can even see out total, all right? I'll do /t, and then I'll put total. Okay, so I'll put total. So let's run this and see what happens. All right, well, okay, I'm still calling display one. So what happens is I have these variables declared, I have my function declared. Then it goes to the main and says, okay, call display one. In display one, it says total. Oh, how does it know? Oh, not total, my fault. It should be what? Sum. Because I didn't use total in anywhere in my program. I used the variable sum. So sum is equal to num1 plus num2, and I'll put sum. All right, and I'll just change this to sum. So we would be on the same page. All right. So now, and what happens is, okay, cause display one is going to say sum is equal to num1 plus num2. Okay. Sum is equal to 0. Okay, so now sum going to equal to num1, which is 3, plus num2, which is 8. So that's going to give us 11. So when our output here is going to output 11. So I'll run the program. It's going to give me my other output still. Program. See, so look, sum is equal to 11 in a function, in a display one function, and then it goes back and out and outputs program has ended. So a global variable declared to be global, you can use it anywhere in the program. All right. Now we talked about scope. All right. So now what happens is if I take this information here, all right, just take this simple declaration and I do a cut, and all of a sudden I'll place it inside the main function. All right. What I've just done is told the computer that I have the same variables, num1, num2, and num3, but now they're only known to what? The main function. Any other function outside of the main function, it does not know what num1 is, it does not know what num2 is, and it does not know what sum is. Okay, so when I use sum here thinking, oh, well, I have it declared up here. Nope. The scope of sum is the main function. So when I run it, I'm going to get errors when I try to use it in display one. See, notice what happened. In the void display one function, sum was not declared. In the void, well, wait again, the num1 was not declared. That's still in what? The void display function. Also, the what? I think if I, yeah, see, num2, num1 is not understood, and num2 is not understood. Now, so what happens is when you're writing functions and you have local variables, in order for the values to be carried over to the call function, that's when you use your argument list. Okay? Now, there's key things you have to do in order to prepare your function to pass values. All right. So the first thing is, like say, looking at your prototype. If you do your prototype, you have to tell it, okay, I wanna have a function called display one. Then it's what? What are my argument lists? Okay. This really is asking what are the data types and how many of them I'm passing. So I'm passing what? Num1, which is what? Int. I want to pass num2, which is int, and I want to pass sum, which is int, because I'm using what? Sum, num1, and num2 in this part of the program. So I want to pass an int, and an int. Okay, so you have to know what it is you're doing in a function before you put it in your argument list. Now, I can't just do this at this point and not do anything in my call, all right, argument list, or my function definition argument list. Now, so in my call function, now I told it I'm passing an int, and an int. Now I need to tell it the actual int variables that I'm passing, okay? In the main function is where my variables was declared. So now I need to tell it what int variables, all right, that I want to pass. So I want to pass num1, num2, and sum, all right? So these are the actual variables that have values that I want to pass. Now, you might say, okay, well, why would you set sum equal 0? If I set sum just to be declared, I will get an error. Because if I try to pass a variable with no value, it cannot be passed, all right? So you have to pass a variable with a value. Now, what we could have done, we could have just passed num1 and num2 and declared sum in here, said int sum, semicolon, and then it would have been local to here, no problem. But I'm just showing you how you pass your values, all right? So so num1, which is 3, okay, will be passed when it passes num1. Num2, which is 8, is here, and it will pass the 8 to the call function. And sum, which is 0, will be passed when we call that function. It will be passed to sum. I mean to display 1. But now we need to tell it and declare variables that we're going to be using in our called function. All right. So we say we passing an int, and an int. Okay, that's our prototype. Here we saying when we call a function, we're passing num1, num2, and num3. That's our list order. So in this function, I need to tell it or create my variables, int, and I can give it the same name if I want. I'll show you how it can be a different name because it's what? A different scope. But for now, we're going to use the same one, num1, right? Then we got the int, num2, and then int sum. So you say, well, Mr. Sylvester, why are we not saying int num1 equals 3? Because it's declared to be, it's initialized to be 3 here. Display is called here, and num1 is known to be equal to 3. That's the value because we didn't add nothing to it or whatever before we called it. So the value 3 will be passed from the main function into num1 in the display 1 function. The value of num2, which is 8, will be passed from num2 to the variable num2 in the display 1 function. And the value 0 for sum will be passed from the main function to the display to sum in the display function. So now I've passed all the values. Now it can say, okay, 0 is equal to 3 plus 8 and store 11 in the sum, and it's going to print sum. All right. So let's run it now. Remember the first time we ran it before when we moved the initialization statement from being global to local, we got these errors. So we made our changes. We added our argument list. We added our argument list in our call, and we added our argument list in our function definition. And notice how they differ. This, when you do the prototype, you just list the data types. And it could have been float, int, char, whatever that list was of the data types you're passing. But then we know we're dealing with 3 integers. So int, int, int. Here is where you pretty much have the list and saying, okay, I want to pass num1, then num2, then sum. All right. And then in your call function, the argument list, you have to give the data type because you're introducing your variable for this scope, int num1, int num2, and int sum. And then you use those variables to calculate your answer. So if we run this now, we should get our same exact answer. So you see what happened? We wrote the program where the variables was declared to be global, and we didn't care. We didn't have to worry about doing any type of argument list. The values was there. It was known all throughout the program. But when we declare a variable local, then that's when it come into play where you have to pass values so that the other function can know what they are. Now, so remember what I said, these the declaration of these variable names doesn't have to be the same. So watch this. I'll change this to N1, all right? I'll change this to N2, and I'll just change this to S. So what did happen here? I'm passing the value of num1 now into an int value in my display 1 function called N1. I'm passing num2 from the main function, which is value 8, into an int value in display one called n2. And then I'm passing sum from the main function, which is 0, into an int variable called s into the display one function. All right. So now, at this point, does display one know what sum is? No, it doesn't, because we've introduced what? New variable names, n1, n2, and s. The values of these were passed into these variables. These are the only variables known to display one. So we would have to change our variables to match. So that would be S1, that would be N1, that would be N2, and then I want to print out S. So now, you see what happens? And I'm going to run the program. The variable names that you pass into don't have to be the same because it's a different scope. So when we pass num1 value 3 into num1 here previously, it was passing it to a different variable with the same, well, it was the same variable name, but it was in a different scope. So it was two different instances, all right, with the same name. So now if I run this, given that I changed these names, I can run my program, and again, I'll get the exact same answer. So you see that? You got the exact same answer. Run it again, and you got the exact same answer, all right? Now, this is one important thing with an argument list. It's very important to match your function when you call in that function, this argument list with this argument list. You will say, well, if I'm passing a value, why does it make a difference? If I did this, if I did something like, okay, I'll leave it like I'm passing num1, I'm passing num2, and I'm passing sum. But then I change this and I'll say int s, all right? Int s, int num1, int num2. Now, I will not get an error in that. Well, I would, because, no, I will not get an error because all my variables, I got my 3 arguments in the list, s, n, n1, n2. They all what? Int. So what? But this is where the problem comes in. Now you may have a logical problem. The problem being num1, num2, and num3 is the order in which the data is being sent. But you're going to receive it into S1, N1, and N2. All right? This is what I mean. Num1 is equal to 3. So you passing num1 into S. So now S is equal to what? 3. I'm passing num2 into N1. So now N1 is equal to 8. And then I'm passing sum into N2, where sum is equal to 0. So I'm passing 3, 8, and 2. 3, 8, and 0. So what happens here, this says 3 is equal to 8 plus 0. So what happens is you add an 8 and 0, and then it's going to overwrite the 3 with 8. So your answer is going to be 8, which is really wrong. So let's run this. And that's simply because, see, look, the answer is 8. And this is wrong simply because what? I have num1 is 3, num2 is 8, and then sum, which I'm trying to find. I pass num1, num2, num3 in an order, but then I'm not receiving it in that same order, which causes problems. It's almost like if you took a test in a class and the teacher received the papers and stacked them upside down as you turned them in. And then what happened, she flipped them back over and told everybody to come back in the order in which they turned them in. you should receive what? Your exact same paper. But if somebody comes in out of line, you know, or skip the line, then what? It could throw all of the papers off, or any of the papers off where that person had skipped the line. So that's somewhat of what's happening here. When you change the order list from what it looked like here, you know, in your actual call function, you have to make sure that it matches to what you want it to be. Because what? If S is my total, you know, or my sum, I cannot put num1 in the S. All right. And then if sum is my total, I can't my sum value, I don't want to put it in the S2 N2. So I have to make sure num1, I'd have a now S could be valid because I could change this to S T, well, if I could type S T and change this to U. You know what I'm saying? If you understand it, you know how it makes sense to you. And then what happens, now you would say what? This would change to be, say U is equal to S, if I could type, S plus T, all right? And then we want to print out what? U. Now, what happened here? We said num1 is S, okay? Num1 right here, okay? We said num2 is T, okay? T is here. So S plus T will give us U, and U is the sum. And so we print out U. So we run it, we're gonna get our 11. So it's understanding how the program is set up. But many times, like I say, you wanna have names where you can really understand what's going on. When you start doing stuff like this and having large programs, you could run into major problems of understanding what you're doing in the program. All right, but so you see how a program can change based upon values being declared as global, variables being declared as global, and variables being declared as local. Now, let's look at this, all right? So I have a variable here. I have sum equaling to 0 here, all right? So what I'll do, I'll change all this back to the way it was when we had it the first time. Int num1, 2, and I'm just changing it so to prove what we was talking about. So now I would say, all right, sum equal num1 plus num2, and we want to print out sum. All right, so now, if we print out sum here, and then what we do, we go back to this main function, and we do cout all right, so what we did, all right, what I did, I just added to the program. Now, we are passing 3, 8, and 0, all right? Num1, num2, num3. We calling this function, we passing 3, 8, and 0 to num1, num2, and sum. We calculating sum. Sum is equal to num1 plus num2, and we getting 11. And we printing out sum, which gives us 11. It outputs this statement here, all right? And then it returns back to this function, to the next executable. And now it's going to print out sum. Now, this is my question. And let me see my chat. Let me open my chat. And you can answer, I guess, in the chat or to the speakers if you want to. What would be the output of sum when we return back to the main function? All right? When we return to the main function and we're doing the cout on sum, what would be our answer? Anybody? We know when we print out sum here, we get 11. But when we print out sum, yeah, in this right here, we're gonna get 11. When we return back to the main function and we're gonna print out sum, what will be our value? All right. Anybody?
0.
0. Who answered that?
Mr. Delay.
Yeah, Mr. Delay. Why would it be 0?
Because sum is declared as 0 in the top.
Correct. And it's like the scope. The scope of sum in here is what? Num1 plus num2. Correct? And you get 11. The scope of sum here, the scope is set to what? 0. So it doesn't know what goes on in this function. When it returns back, it says, okay, print out sum. It's saying, okay, here sum is 0, so it's going to print out 0. So let's run it. All right? And that's the correct answer, 0. So see what happened? It prints out 0 because what? In this function, what did we do to sum? We just initialized it to 0. We didn't add to it or do anything else. We passed the value of 0 here. We added in here, but what? Sum is here, right? So and look, these variables are passed by value, okay? Because there's another way you could pass it. We pass these variables by value, by the value alone. We just passed the 3, we just passed the 8, and we just passed the 0. That's it. When we return back, num1 is 3, num2 is 8, and sum is 0. Now, if we pass these variables a variable by reference, though, and that means by its address, then it will be changed at its address. Now, you said, well, Mrs. Sylvester, what you mean by that? What I mean by that is, in order to pass a value by reference or its address, you simply signify the ampersand, all right? Using the ampersand. The ampersand says, okay, we're not concerned with the variable, we're concerned with the address. Because remember what happens when we say int x equals 0, what actually happens is the system says, okay, go into memory, allocate some space for x, and we're going to put in an int value, and whatever that value is, if it's 0, we put in 0. Now, another important thing we didn't really kind of harp on is, remember we said different data types have different what? Well, you can say memory sizes or byte size. Because what? A char value has what? Allocate what? 1 byte. A short int is 2 bytes. A int is 4 bytes. All right? And double and int and float, I think, is 4 bytes. Double is 8 bytes. So you see the difference? So the system, when we use the address, it knows wherever it's put in, if it's an int value, this is the address. And now I have to reference from this point across these 4 bytes. Whatever that value is, I'm going to take that and use that to do my manipulations. That's somewhat of low-level programming, which allows the system to run a little faster. Now, what I did here, I changed this to say I want to pass by reference. So now, I can still say I want to pass what? Sum. So I'm just passing sum. But it knows that I'm passing what? The address of what? Sum. And here, I need to tell it I'm passing an address. So now, when I pass sum, all right, now what happens is, and I think I need to put it in. Now, I think I need to put it here too. Now what happens when I run it, it will give me the value here, which is 11, but whatever is done here, it's also done what? At that memory address. So when we come back to print out sum here, we still will get what? Well, I mean, we'll get what? 11, because when we passed it by reference, we said whenever we use sum, change it at its address. So it's going to change it. And I think this is right. Okay, I run it. And see what happens? Now, the only thing I changed was I want to pass it by reference, so I added an ampersand. Then what happens in my function definition, when I created this int value, but this last one, I'm creating an int value with a memory address, because that's what I'm passing, a memory address. And now when I use that variable, whatever I do to it here, it's automatically done, and when I use it again, it will be the value that's at that address. All right, so that's passing by reference, okay? But if I didn't want to have sum to be changed, then I would not pass by reference, okay? But in some cases, sometimes you may want to have a value change, and you don't want to say return or whatever, so you could say, okay, I'll just pass it by reference, make my modifications in an expression in that function, and then it's automatically changed. All right. So everybody see that when it returned back, the sum was what? 11. The exact same thing it was in here, because I did what? I did it by reference, not by a value. All right. It's almost, how would I say it? It's like somebody may know your name. If somebody know your name, they can reference you. You say, okay, I know who, whatever. But if somebody know your address, say like your home address, they pretty much can go to your address and say, yes, I know them, I know whatever, and they have access to make those modifications. But just knowing the name is like, okay, I got the name, whatever that value is, I use the value, and that's that, and I'm going about my business. All right? So it's a kind of bad analogy, but that's somewhat of what references is. It references that address, and whatever changes are made to that variable, when it's passed as a reference, it is changed. And when you use it again, it'll be that changed value. All right. So, and you can pass any number of variables by reference, any data type by reference. All right. All right. Anybody with any questions about the function? Now, another thing, okay, we did it by reference, but let's say I told you write the program, and I didn't want you to pass the variable by reference. I want you to return the value of sum, okay? If I would tell you that, then you would not use reference, all right? I would say, okay, write the program, calculate that passing these local variables to a function, calculating a sum, the sum of those two numbers, all right? But then return that value of the sum and print it in the main function. Now, if I run this the way it is now, remember I took the reference off, so now it's gonna print what? The 11 from here, and it's gonna print 0 from here, right? So when I run it, it's back to the original state, all right? 11 and 0. Now, if I want to return the value of sum, all right, it's a couple of things I need to do. One thing I need to do is I need to change my prototype of my function here. So I need to do what? What I'm gonna want, what type data I want to turn? An int value. So I have to say int. So this signifies that some value is being returned, just like we did with the main, return 0. All right. So, and we could return a constant, or we could turn an expression, or we could return the value of a variable. So here I would have to change my function header. I'd have to change this to int. Okay. So now that signifies that something needs to be returned. So now I need to what? I need to say here what? Return. And what I say I want to return, I want to return the value of sum. So now, whatever's being calculated here, and I get sum, and sum should be 11, it's going to output enter display 1 function, and then it's going to say, okay, before I go back to the call function, I'm going to return this when I go back. So when I return back here, it'll go to the next executable statement. But I need to do something in order to retrieve that value back to that call function. I need to introduce a new variable. So now I could say int, and I could call it anything, val is equal to. What I've just done is says, okay, when you call this when this function is called, all right, I want to return whatever's returned back from that function. It's going to be equal. It's going to be assigned to val to val. So when we return sum going to be returned to what? The value of sum going to be returned into what? Val. And now I can print out val. I'm gonna leave sum there, and now I'll just print out val. All right, okay, I'll do a cout, and I'll do val. Because sum's still gonna be 0. So sum will still be 0 because of this scope. But the value of sum being returned will be returned in the val, and when I print out val, it's gonna give me my total. All right. So when I run, my sum. So now when I run it, see, my sum is 11. I return back. Sum went back to 0 because it wasn't passed by reference. But I returned the value of sum here back into a variable called val, and then now I got that value from that function. So that's one way to get that value back from that function. You can return it, okay? So everybody see that? That's returning a value, okay? Now I could do it this way. I could have just said int val at the top and then val equal to, but I just did it all at one time. Int val is equal to whatever this function returns. All right, and this function could be doing anything. Have some if statements, whatever. It could have 20 lines of code, 50 lines of code, but val is gonna only equal to what? Whatever whatever sum return when what sum is when it returns. That's all it's going. That's all val gonna equal to. No matter what you printing out in the program in that function, it's after it does all that, it's returning val. Returning sum, and sum is being placed in the val. Okay? Any questions? Anybody with questions? So that's pretty much dealing with functions, all right? Like I say, dealing with functions, sometimes you don't need an argument list, all right? If you did everything global, you can write the program, simple program is done. But then you could write a program where you pass in the value, okay? And you pass the different values. Then you can write a program where you pass in by reference. When you pass by reference, with any changes you make to that variable is automatically known and changed in the program. All right. And then what? You could return a value, and you could return any type value. You could have char and then return a character. All right. It could be a double display, whatever, and then double display and whatever this is, because this could be all in, but I'm gonna return a double. Then I return my whatever value, and then here I could say double val is equal to, because what? I'm returning a double. Double val equals to whatever this is. All right? So it doesn't have to be just int all the time. It can be a char data type that you're returning. It could be a Boolean value that you're returning. It could be a string value that you're returning. Whatever it is. So any type data type can be returned. So like I say, don't try to think closed-minded. Think outside the box. Like I say, this is the data type. So any type data type can be returned. Any type data type can be passed when you actually pass in values. All right. So now, and there's a way to pass arrays, but we'll get to arrays later. Let's look at our assignment. The two assignments that I have for you, and they dealing with global and local variables, I think, chapter 6. All right, so let's look at this program. All right, simple program, but you got some things you got to do inside. It says, write a C++ program that will allow a user to input a length and a width of a rectangle. All right, so that you're asking the user for their input. All right, Once entered, calculate the area and perimeter of a rectangle. Now, we know the area of a rectangle is what? Length times width. We know the perimeter of a rectangle is 2 lengths plus 2 widths, right? So, like I say, you need to know those the two different operations. Sometimes when you use a certain number, you're gonna get the same answer, but you need to make sure your calculations, your formulas are correct, because I might put in different numbers. All right. So I want you to write that program to calculate the area and the perimeter. Then output the length, the width, and the perimeter and the area. Make sure that you label label your outputted values. So length, whatever length was, width, whatever width was, perimeter, whatever perimeter is, area, whatever area is. All right. Now, that's what you're supposed to do. This is how you do it. It says use a function to accomplish this. So now what? You're writing a program, but in that function, you're gonna have a user say what? Please input the length. Please input the width, right? And then calculate whatever and print. Now, look what it says. Declare your variables as global variables. So where we declare the variables? Above the main. All of the variables like int length, int width, length, int area, int perimeter. All that's declared where? Above the main, outside of any function, even the function you creating. All that is declared above the main. All right. So you're using a function to do that. You're declaring your variables. Then it say create a function to output the data. All right. Calculate, output the data, calculate the area, perimeter, and print the results. So basically, declare the variables, ask the user to input a value for length and width, call the function, calculate everything, and then print everything. All right. Being that the variables are declared global, you don't have to what? Pass any values. Okay. That's the first program. Second program is identical in that you're doing the exact same thing, but this time, just like we did in our program, I want you to take those declarations and place them within the main function. So let's go to the second one. Well, I need to publish this so that it'll be there, because I might forget. So let's publish this. All right. So today is the what? 20th. So it's the last week. I'll make it do Friday. I'll say Sunday. I'll make them not this. Oh no, not down. Go back here. It's June. May 3rd. All right, May 3rd, 11:59. Pushing it, but I'll give you all that time. All right. All right, May 3rd, 11:59. All right. I did that. No, so I'm gonna publish it. Publish that. Now, let's look at the next one. Same identical program. All this is exactly the same. But this time, you're declaring your variables inside of the main function, all right? Because look, locally declare your variables within the main function. So inside the main function, you're going to declare the variables, then you prompt the user, and you're going to prompt the user also in the main from the other program. So you're going to prompt the user in the main to input a length, input a width. But in this one, this same one, you're going to declare the variables. Just take that line, copy the program, take the line of the declarations, all of the declarations, the length, the width, the perimeter, the area, and place it inside of the main function. then prompt the user to input a length, prompt the user to input a width. Then you're going to pass the values to the function and do your calculations and print out in that function. All right. Now you can do it in two ways. You can pass the length, the width, the perimeter in the area, but make sure when you do that, you set the values to equal to 0, because you cannot pass. Remember, I said a variable that has no value. All right. So you have to set the parameter equal to 0, the area equal to 0 if you're passing it. Otherwise, you can declare them, the perimeter and the area in the function that you create, but only pass the other two, the length and the width. Okay, but like I say, declare the variables locally, pass them, and then calculate your information and print your information from the main function. All right, from the called function. All right. Now I could have told you write the program to pass the values by reference, calculate whatever, and then print in the main. We could have done that, but we're not doing that. We're doing this one. We're doing the one with global, so you can see when something is global, I could just use it anywhere, anytime. But that could be dangerous when you're programming. It could be hard to code. In this one, the program, the variable is going to be local, and then you're going to see how I have to be able to send the value to the function. Otherwise, the function won't know it. I have to make sure my argument list is properly set up. Otherwise, I'm going to get some type of errors. So make sure you stay in line with the guidelines of what we talked about. The function, the order list of your variable being passed. Make sure your value is going to the right variable, because you could mess up. So things of that nature. So be aware. So those are the two programs. Let me edit this one, and I'm gonna publish this one. All right. All right. So those two are published. Now let's take a look at. Okay. Let's take a look at chapter 7. All right. So we looked at pretty much most of it. Let's look at chapter 7. All right. Chapter 7 deals with arrays. All right. And if we look at it, all right, it deals with arrays. And what it tells us is arrays hold multiple values of the same data type. Example, in our previous program, we had num1. Num1 can hold only what? One value at a time. Now we could keep what? Overwriting it and overwriting it and overwriting it, but num1 was only able to handle what? One value for that variable name. But when you dealing with arrays, you can allocate space that is contiguous in memory, so that what? I can reference each value that I have in my array, depending on how large my array is. So it says that an array allows you to store and work with multiple values of the same data type. All right. So notice, and like I say, what we've been working with, and we say int count. Int count could be count itself. The variable can only be one number. It could be the value 1. It could be any other value, 2,000. It could be 300, but only one value at a time. All right. Same thing. Price can be only one value. Char letter can only be one value. All right. So what happens is we can create an array. All right. And like I say, you got arrays, char arrays, int arrays, string arrays. So you have different type arrays. So what happens when you declare or create an array creates values of elements that can have memory locations for each value. Now it goes back again to, if I create an array of integers, then each memory location is 4 bytes long. The first one is from wherever the starting point, 4 bytes. The next one, that starting point, 4 bytes. The next one, that starting point, 4 bytes. So, and then if I do something as char, 1 byte. So the first byte, then the next byte, then the next byte, 1 byte each for a char array. All right. So what happens is you have elements of the array. Now, when you create an array, you must allocate enough space for all of the elements that you want to put in that array. If you don't, you can run the risk of going out of the boundaries of the array and causing problems in your program. It's no problem to allocate more space, but you can run into problems if you don't have enough space. Now, it's not a good habit to just say, okay, well, I know I'm dealing with arrays, and so the teacher say, write this program dealing with some numbers, but I'm gonna make my array, say, 20,000. Well, what you're doing is you allocating it so large that really you're wasting space. All right. So many times you may not know the size of your array, but at the same time you don't want to make it so large that you have a ridiculous large number, and then you allocating all this space that the system will have to allocate and reserve for the array, and it's never being used. All right. So you got to watch that. So if you look at it, like I say, short 2 bytes. This says short hours 6. This means that I have a variable called hours of the data type short, and I have 6 elements. Now, just ask you off the top of your head, short has a data type where it allocates 2 bytes per memory location. So if I have a short array, short of 6 elements, how many memory locations or what size bytes of allocation is needed? How many bytes? It would be 6 times 2, which is 12. So I would need 12 bytes so that I can allocate contiguous space for my array. If I had an array of int with 10 elements, that would be 10 times 4, because what? Int has a byte size of 4. So every element, 4 times 10 is 40. All right? So that's how you would calculate that. And look, this is to give you an example here. Char letters have one byte, take up 1 byte. Char, so what? If I have letters of 25, that's 25 times 1, that give me 25 bytes. Short 2 times 100. Int 4 times 84. Float is 12. Float 12, float is 8. Float is 4. Float 12, that's 4 times 12. And double 1,000, that's 1,000 times 8. All right, and that's how they got these numbers here, multiplying the number of elements times the byte size it takes for each element. All right, so let's look at arrays. When you access an array, you have to access it by its subscript. All right. What happens is, remember we said that we start counting at the number 1. That's just how we train from small. Start at 1 and go on. But a computer always starts at 0. All right. It starts at 0, and we got to keep that in our mind. Computer starts at 0. All right. Now let's go to online GDB and see why that is. All right. For many instances, what happens is, I'll just take all this out. All right, I'll say return 0. Now, how do I create an array? All right, to create an array, okay, I could create it globally. Create an array, I could say int, and I could say num, and then square brackets 10, all right? What have I just done? I've just said that I want a variable called num that's to be, and when you see the curly brackets of an array size 10, and it's int. What's the number, what's the byte size But for that allocated array, 10 times what? 4, right? So that's 40. So let's change this to 5. So we want an array of 5. Now let's do this. So we know we have an array of 5. So let's try this. Let's do something like CN or Cout. I'll do a for int x equals, if I can type, equals 0, x less than 5. Because 0 to 4 is what? 5, right? And now you see why we be doing that many times. 0 to 4 is 5. So 0, 0, 1, 2, 3, 4, I can read through my array without what? Going over out of bounds. All right? Even though I have 5 elements, it starts at 0 and ends at 4, you know, less than 5. And then I'll do x plus plus. Now, what I'm going to do is I'm going to tell the system to read in, all right, Cout, enter number. All right. Now what happens here, I'll do a number, and then, and I'll just do this, just so we can see, and then x plus 1. Plus 1. So each time it goes through, I'm not assigning it, but I'm gonna output number in a number, and it's gonna print 1. All right. All right. And then I can put and then, all right, and then CN. Now this is the thing. Num is my variable. Anytime I reference num or element in num, I have to use it with a subscript. All right. So if I want to use, I want to reference each individual element. Here, x is 0, then x goes to 1, then x goes to 2, then x goes to 3, and then x goes to 4. So what I could do here, I could use x as my reference point. So what? CN is going to really say num sub what? 0 the first time. Next time through, CN num sub 1, then num sub 2, then num sub 3, then num sub 4. And what I'm actually doing, I'm actually storing values into my array. All right. So I'll do this. And then what I'm going to do, I'm going to write a for loop. I'll just take this rather than try to type it. I'll take this. All right. And I'm going to output the information. So all of a sudden now you see that what? We can actually take information, input it, and then we can have it and reference it without having to re-enter information. So now I could say Cout, I'll do /t, and I'll just say num. Well, no, and then I'll do num again sub x. Now you might say, well, Mr. Vester, you use x right here. Look, this is a scope for int x equals 0 to 5. So once it finishes this, that scope has ended. It start a new scope for int x is equal to 0 less than x less than 5. That's a new scope. So you see, x is not being conflicted with the different scopes. So now, this one allowed me to input the values. This one allowed me to output the values. So when I run it, hopefully I got all the errors out. All right, see, enter number 1, right? So I'll put 10, enter number 2. And that's how I got the 2, the 1 into 2. X at the first time is 0. I just say output x plus 1. X plus 1, which is 0 plus 1, I get 1. So now I'm what? I'm just kind of shifting my array, shifting my subscript over one, so that we as the person inputting can have it understood. We're starting at 1, but the computer really starts at what? 0, because we're doing num sub 0, num sub 1. So I'll put 20, 30, 40, 50. Now, remember, the previous programs, once I put a number like that in, I cannot go back and retrieve it, because it either being overwritten or something, correct? But now, if you look at this, I read all the numbers into this array, num, right? So now I could go back and say for x is equal 0 to whatever. Now I want to output each one of those numbers. So I've inputted them here. When I hit enter, now we should output them. Notice what happened. So it retained, an array can hold the values for you, where you have one variable and multiple elements, okay? That's how an array works, all right? You reference it by value. Now, look what you can do. But that would be a dinosaur way, but to understand it. If I did something like this, and what I'm gonna do, I'm gonna run it again, and I'm gonna put these same values. If I said cout num, and I'll do sub 3, and then I'll do something like this. I'm printing out that actual position. What will output? If I put in these same values, what number will output?
30?
0, 1, 2, 3. Remember, we start at 0. We start at 1. The computer start at what? 0. So num sub 0 is 10. Num sub 1 is 20. Num sub 2 is 30. Num sub 3 is 40. So it would print out 40. So let's test our theory. Let's run it. All right. We're going to enter the same information. All right. So if I put in 10, 20, 30, 40, and 50, see? Num sub 3 is 40. You got what I'm saying? Because the computer starts at 0. We start at 1, but the computer starts at 0. And even when you're dealing with character, same thing, because you can have a character array. All right. So this is somewhat of arrays and how they work. And you'll get into 194 and you get more in depth in arrays. You also going to deal with vectors. And there's another thing. There's something called two-dimensional arrays. All right. You know how you might have, then you got three-dimensional arrays. Example, you might have to write a program where you're dealing with seating in a stadium, and it might even go to 4, where you got a section, a row, and a seat. You understand? So you have to keep track of all those different things. When they do tickets, you got that section, then that row, and then that seat number. So that's 3 different elements. Could be a three-dimensional array where you're trying to program and manipulate that data in 3-dimensional, all right, in 3D. Then you got 4D, 5D, whatever. It can get as deep, and the deeper you get, the more difficult it gets. All right. So, and then I could even add another loop. So I'll take this out, because like I say, once your information is in your array, it's just stored there. So I'll copy this loop and watch this. Or I'll ask the question. We'll do it together. I'll copy this and I'll paste this here. Now, we know that this one will print out what? Num, here. Now, I want to know, how could I print out the information how could I print out this array in the numbers in reverse order? How would I do that? First of all, how would the output look in reverse order? If I type in these same numbers, 50, 40, 30, 20, and 10, correct? So if I want to print this array out in reverse order, so I need to start printing what? Num sub 4, num sub 3, num sub 2, num sub 1, and num sub 0. So what? All I need to go is here and say for x is equal to what? 4, right? X greater than or equal to 0, and not plus plus, but what? Minus minus. Now all of a sudden what? It's going to start at 4, come back through, it's going to decrease to 3, decrease 2, decrease 1, decrease 0, and then stop. All right? So you see how, if you know how your loops work, there's ways in which you can do whatever. So 10, 20, 30, 40, and 50. Now when I hit it, see here, this is the order that it was typed in. This is the reverse order. Okay? Now, let's do this. I'm going to take this statement out altogether where I was actually inputting in the values. I could initialize an array if I want. Equals, and then I use the curly braces, and then I could say 10, 20, 30, 40, 50, right? And then close curly brace. So what I'm doing here, I'm giving my array values, right? Now, I can say 15. I could always increase the size. That's no problem. I can have an array allocated larger than the size I'm initializing. That's no big issue. One downside or one thing you can't do, you can't have no value, all right, in the middle, all right? Once you stop initializing, you have to stop everything beyond that. I could do just 10 and stop and have an array size of 15, everything else would be 0. But I can't say, okay, I want the first element to be 10, I want to skip the second one, and then the third one 30. No, can't do that. Now I could put 0, that's a valid number, but I can't just leave it blank, all right? So that's one thing you can't do with arrays when you initialize them. So I'll do 20, we know it's 5, so I'll leave it at 5, all right? Now watch what happens. I won't have to do anything. All I have to do is just run it. See what happens? The values are already given. So what? I have a variable called what? Num. It is an array of how many elements? 5. 1, 2, 3, 4, 5. What's the data type? Int. And once I do that, I can use that array as many times as I want, whenever I want, no problem. Watch this though. I could change a value of an array. So say we said what? Num sub 3 was what? 40, right? Correct? So what I could do is right here, I could say num sub 3, if I could type, num sub 3 is equal to 1,000. Now, the first time it print, it's going to print what? This array here. The second time it's going to print the exact same array, but num sub 3 going to be 1,000 because we just changed the value at this what? Location, all right? So it's going to change this from 40 to 1,000. So you can manipulate your array where you could change value. So if I run it, see what happened? So 1, 2, 3, 4, 5. This was the first list that was initialized. But then before we printed it the second time, we said num sub 3 is equal to 1,000. So what? 4, 3, 2, 1, 0. So see how you could change that? Now, if I wanted to add elements in an array, I could do that. I could say cout, and then we'll go. I say cout, and I'll do something like this, and I'll do /t. I'll say sum, all right? And now I could say cout the sum of, and I'll just put it here. I didn't set it equal to none. I could say num 2 plus num 3. Now, what's that equal to? 40 plus 30, right? So that should print out 70, correct? So when I run it, this time, see, I should have did I should have did I did an inline. Oh, at the end of it. Yeah, so you can see. All right, let me run it again so you'll see. Run it. So you see here, the sum was what? Num2 plus num3. So what? Num2 is what? 30. Num3 is 40. So 30 plus 40 gave us what? 70. So you can add them, you can multiply them, or divide the values of those rate position, whatever. Compare them. If num1 is greater than num2, whatever. Just like if it was an actual value. All right. So that's arrays. And like I said, a lot more with arrays, but at least we kind of touched upon it. Anybody got any questions about the assignment? So what I'll do, I'll post, and I need to post test 6. And I'll post test 6 for this week up until the 3rd. Now, how many people started doing the practice exam? I'm gonna post the assessment out again too. All right. But make sure you go through the practice exam. Try to go through it as many times as you can. All right. So that you can kind of get become familiar with C++, understanding the questions and whatnot. All right. So I'll post the test. Any questions? Anybody? Any questions?
Sylvester, can I talk to you one-on-one after you're done?
Oh yeah, okay. Yeah, we could talk. All right. Oh, the practice exam is out. Okay, let me do the final. The final is already set. So I need to do test 6. All right. So I'll open up test 6, edit, and that'll be the 3rd 2 times. And all the makeup should be open too. All right. All right. Ha. That should be the 3rd. Third. Oh, that's June 3rd. I'm doing it wrong. Here we go. April. Wait a minute. Oh. Wait a minute. I'm in 1900. Wow. Okay. There we go. Yeah, I'm a century behind. Okay. All right, so the test has been published. Make sure you take the test. All right, it's open, so you can take it. All right, if there's no questions, like I said, I'm gonna talk to Mr. DeLay. If there's no questions, I'll talk to y'all. Like I said, the final exam, it'll be open on Tuesday. From Monday. Maybe I could just kind of go online, open up a session and just come on. And if anybody got any issues or questions, if not, I'll just shut it down. But I might just open it up during that class time just to make sure everybody on the same page. If nobody log in, have any issues, then I'll just close it down. And that'll be Monday next week. All right. So like I said, if you don't have anything, I'll see you all on next class period. Do my work, do my tests, do my makeups, and make sure you do my assessment again. I need to post it again, so make sure you do that. All right. So I'll see y'all. Let's say if you got anything on next class period, but do my work. All right. All right. Let's see. I tell you what, Mr. DeLay.
Yes, sir.
What I'll do, I could just reopen it at another time for you.
No, I just a quick question. Was it just the quizzes that you were letting us make?
Quizzes and tests.
I think my tests are still locked. If I'm not
Which
mistaken.
one?
All of them, I believe, and maybe I just looked at it wrong, but I think they were still locked. That's why I wanted to ask you that. If they were still...
Let me go back to modules. Let's see. I doubt it though.
Oh no, they're open. I'm sorry, they're open.
Yeah. What happened? They opened today though, I think.
Oh, okay.
They opened this morning. Last night at 12.
Oh, okay, because I was looking at it yesterday and I was like,
Right. But I think at 12 o'clock last night they opened.
Okay, I think that's all I needed to know. Thank you so much.
All the tests and all the quizzes are open. So you can you can retake them. They can say if you didn't take them, you got those 3 opportunities to take them. You know what I'm saying?
Okay.
Yeah.
All right.
And,
that was it. Thank you.
And you got to remember the final exam. You got to use that webcam.
Okay.
All right. Yeah. Make sure that's set up.
Okay.
All right. So I'll see y'all on Monday next week.
All right.
All right.
Huh? What's that?
No, nothing.
Oh, I thought somebody was saying something.
Yeah. Oh, Kafago
Huh? Oh, all right. So I'll see y'all on next class period. Let me close this up. Question.